Hello, geometry students. It's Mr. Zabo. Today we are going to talk about sections 2.3 and 2.4 in our textbook, and what we are looking at is drawing conclusions, and then talk a little bit more about complementary and supplementary angles. So first, let's look at drawing conclusions, and really what we're looking at is how are we really structuring our proofs based on what given information that we have. So for example, if I have been given that a ray bisects an angle, specifically in this diagram that ray AB bisects angle CAD, the conclusion is specifically that this angle, angle CAB, is going to be congruent to angle BAD. So angle BAD. Okay. And so this is what it would look like here in a flow proof. We're not doing flow proofs, we're doing two-column proofs. So this is the conclusion that we are drawing. And I can write it all out a little bit neater here, right here. That's the specific conclusion. Essentially, this is what the statements section in our two-column proof is going to look like, where we're going to first state that ray AB bisects angle CAD, and then the reason for that is that it was given. You always have a statement and a reason. And then the conclusion can come after I've made that statement that angle CAB is congruent to angle BAD. And then we need a reason. And the exact definition is this, that if a ray bisects an angle, then it divides the angle into two congruent angles. That's going to get real cumbersome if I ask you to write that out all the time. So I can abbreviate it. And here's how we would abbreviate this. The given is that we have a ray bisecting an angle. So I'm going to say ray bisect angle. Then, we can use the arrow for then, two congruent angles. Much easier. Okay? Ray bisect angle, then two congruent angles. In this next example, there's two conclusions that we can draw from our given statement. So in our diagram, we know that segment VI bisects segment CD. So what that's telling me, a segment is bisecting a segment. Segment CD is what is getting bisected. These are my congruent statements then. That segment CI is congruent to segment ID. Segment bars are mandatory. The congruent statement is mandatory. But I can take that a step further. Now that I know that those are congruent and it's obvious that they are collinear, I can also state that I is the midpoint, and I can abbreviate that, of segment CD. So again, these three statements, the given, conclusion one, conclusion two, in that order can go down as statements in my two-column proof. Again, at this point, the given statement has a reason of given. Now I need two new reasons. Again, the order here mattered. A segment bisecting another segment implied I had congruent segments, not a midpoint. Congruent segments implies that I have a midpoint. So by definition, if a segment bisects a segment, then it divides the segment into two congruent segments. That's too much. I'm not going to make you say that. Okay? But what I will ask us to write is, and this is going to be even easier because this is segments, I'm just going to say bisect implies two congruent segments. If you switch this and say angles in this problem, it's wrong. Okay? Same idea here. If I say bisect an angle implies two congruent angles, correct. If I said bisect angle implies two congruent segments, incorrect. That's why sometimes I'll have my students here, instead of just say bisect, I'll say bisect what? I'll actually leave a little room here and say it might make more sense for you to say, okay, bisect a segment, that implies you have two congruent segments. Now what do I have? Well, I have two congruent segments. So two congruent segments implies midpoint. Yes, the abbreviation is leaving out the fact that those segments are collinear, that my 3 points are collinear. That is true in the actual definition. Two congruent segments does not actually imply midpoint. Two congruent segments where the middle point is collinear with the two outside points. But I'm not going to make you write that in a 2-column proof. That's a little bit too much. All right, so that's it for section 2.3. It's a general idea. We'll get more practice with that in class, but taking a given and then coming up with conclusions from that. That's the key to writing proofs, is given information, what conclusions can we draw from that? Next, I want to talk about some theorems, and this is going into section 2.4. So the first one is about supplementary angles. It says that if angles are supplementary to the same angle, then they are congruent. So if angle 1 was supplementary to angle 3 and angle 2 was supplementary to angle 3, if that was known or proven or given, we then could conclude that angle 1 was congruent to angle 2, since they're both supplementary to the same angle. And then skipping one, very similar thing can be said about complementary angles. If complementary angles, or if angles are complementary to the same angle, the key there is same angle, then those angles are congruent. Then they are congruent. So supplementary to the same angle, they're congruent, or complementary to the same angle, then they're congruent. Our other theorem is a little different though, because it says that if angles are supplementary to congruent angles, not the same angle, then they are also congruent. So if they're supplementary to the same angle, it's 1 is sub to 3, 2 is sub to 3. Well, they're both 3. Here, I have angle 1 supplementary to angle 3, and angle 2 is supplementary to angle 4. That's not enough information to draw any conclusions. I would need an additional statement that said something like angle 3 is also congruent to angle 4. Now I can draw a conclusion. 1 is supplementary to 3, 2 is supplementary to 4, and 3 and 4 are the same thing. They are congruent. Now angle 1 is congruent to angle 2. And then similarly, the same thing happens with complementary angles. Complementary to congruent angles, they are congruent. All right, now let's take a look at a proof and get a little bit of practice with that. Here we were given that segment KF is perpendicular to segment KJ. KF and KJ, that's a perpendicular angle. That tells me that angle FKJ, or JKF, is a right angle. I'm just going to abbreviate up there. Then segment JH is also perpendicular to segment JK. That tells me that angle, wrong angle, HJK or KJH is a right angle. They also tell me that angle HJG, H to J to G, this angle is congruent to FKG, angle FK to G, this angle. And what they want me to prove, and so I'm not going to mark it in my diagram, is that angle GKJ is congruent to angle GJK. So GJK is this angle. They want me to prove that it's congruent to angle, or that's GJK and then GKJ, this angle here. Well, this is going to be one of the theorems we just talked about. I know these angles are congruent. Can I somehow find a statement that says these other angles are supplementary or complementary? And the answer is going to be yes. So while there are a few ways to do this proof, I want to use some of these theorems that we just came up with. So now that I know I have a right angle, I can conclude that we have complementary angles. Specifically, that angle FKG is complementary to angle GJK, and that angle HJG is complementary to angle GJK. Now that I have two angles complementary to congruent angles, so angle HJG
I know is congruent to angle FKG. So angle GJK and angle GKJ, one of them, this one should be angle GKJ, so FKG and GKJ are complementary to congruent angles, then those two angles are going to be congruent. So this is the outline of it up here. We can now write that out in a full or in a two-column proof. And I like to do it this way. There's multiple ways to do this, not infinite ways, but multiple ways. I like to take one given and draw it all the way out till its last conclusion before I need another conclusion. So I start with these segments being perpendicular, given, then I have a right angle because perpendicular implies a right angle. Now these two angles are complementary because right angles imply complementary. Next, I can't go anywhere with that logic statement, so now I have to continue on to my next given. So I take my next given statement, I have to write it as a statement and use given as the reason. I have to make sure I have all of my angle names correct. As I move on, I can state perpendicular implies right angle again, or state same as number 2. And now state my complementary angles. Again, making sure that I've named my angles correct. That's one thing I am looking for when I am looking through your proofs. Now I have two angle pair complementary statements. I have another given that I have to make sure I mention. And so I mention that my angles are congruent, and now I can look at my statements. In statement 3, I have angle FKG, and in statement 6, I have angle HJG that I have both stated in number 7 are congruent. So the angles I'm trying to prove are complementary to congruent angles. That's going to be my last statement, that my angle GKJ is congruent to angle FKG, or angle, letters, GJK, and then it's going to be my reasons from up top. And that states that if two angles are complementary to congruent angles, then I can just state congruent, or angles are congruent. And so my two angles are angle GKJ and angle GJK. They are complementary to congruent angles. So I have stated that they are complementary. I have stated that the angles are complementary to or congruent. I can now conclude my two angles are congruent. So that's it for this video. When we are in class, we're going to get to practice this a little bit more and a few more of those theorems as well. See you guys in class.